Today we're going to discuss Chapter 3, Petroleum and Synthetic Materials. We're going to start with the idea of cracking. From its name, when we say cracking, it means breaking down of a hydrocarbon into smaller hydrocarbons. The conditions to perform a cracking reaction, we first need high temperature. We do not need oxygen to be present, so high temperature. In absence of oxygen, we will get an alkane and alkene. So always when we break down an alkane, the products will be a smaller alkane and a smaller alkene. Since it is a chemical reaction, cracking is a chemical process. We can look here on the slide and see that we have decane. Decane, as we know, is an alkane made of 10 carbons. So if we look here, we have 10 carbons. If we want to break it down, we have two products, an alkane and an alkene, as we said. The alkene is propene. Why propene? Since it has 3 carbons, so we call it propene. And the second product is heptane. So if we count the carbons, we find there are 7 carbons. All bonds are single, so it is heptane. Law of conservation of matter. According to the law of conservation of matter, the number of atoms of each element is conserved. So if we look here at the example, we're continuing with the same reaction. C10H22, decane. We said we need high temperature, no oxygen. We have two products here. One is C2H4 and the other is C8H18. Now if we count the carbons, on the left we have only 10 carbons in decane. On the right we have 2 carbons and 8 carbons. So we have as a total 10 carbons on the right. If we count the hydrogens, we have in decane 22 hydrogens, while on the right in the products we have 4 and 18 for a total of 22. So according to this law, the number of carbons remain the same, the number of hydrogens remains the same. We cannot have different numbers of carbons and hydrogens in the reactants and the products. Why do we use this law? Sometimes we have a reaction with a missing compound. So if we look here at this reaction, we have C8H18, the product, the first product, CXHY, so unknown. We do not know how many number of carbons, how many number of hydrogens are present in this compound. The second compound is C2H4. If we look at the formula of C2H4, we can deduce it is an alkene, since the number of hydrogens is double the number of carbons, so alkene. The second product, CXHY, should be an alkane. So we said in the products we always have one alkane, one alkene. The alkene, we already know it. We need to find the formula of the alkane. We apply the law of conservation of matter. We say we have 8 carbons in the reactant. In the products, we should have also 8. So 8 in the reactant should be equal to the X, the unknown, and the 2 which are in C2H4. By solving this formula, we get that X is equal to 6. So now if we add them together, 8 in the reactants, 6 plus 2 in the products, we have 8 carbons. For the hydrogens, we apply the same law. We have 18 hydrogens on the left. On the right, we already have 4. We need to find Y. So we say 18 is equal to Y plus 4. By solving it, we get Y equal 14. The final answer of this compound will be C6H14. How do we verify our answer? It needs to be an alkane. If we look at its formula, 14 is double 6 plus 2, so it corresponds to the formula of an alkane. We finished the idea of cracking. So to repeat, Cracking is the breaking down of an alkane into a smaller alkane and an alkene. The number of carbons and hydrogens should remain the same. By applying the law of conservation of matter, we get the number of carbons and the number of hydrogens. Now for polymers. What is a polymer? A polymer is a large molecule. We call it a macromolecule. This large molecule is formed by joining together smaller molecules called monomers. So monomer, from its name, mono means one, poly means many. We join small monomers to get a large compound which is called a polymer. So the polymer is made of many small units called monomers. Now when we join together these monomers to form a polymer, we call them repeating units. So we have at the beginning monomers, we join them together, we get a polymer. In this polymer, we call the small units, we do not call them monomers anymore, we call them repeating units. Now if you look at the monomers, in this polymerization reaction which we're going to study, the monomers will always be alkenes. So they should have a double bond. When we join them together, we remove the double bonds and we keep the same number of carbons and the same number of hydrogens for each repeating unit. So the difference between the monomer and the repeating unit is that we remove the double bond and we connect it to another repeating unit. The general polymerization reaction, we write it as follows. We start with the monomer. Since we do not know how many polymers or how many monomers we're going to use, we write before the formula of the monomer small n. This small n represents a certain number of monomers. So we said we need many monomers in order to form a polymer. We write a small n representing the number of monomers which is unknown. We do not know how many monomers we have now. In the products, instead of writing the monomer several times, since we do not know how many monomers we have, we draw the repeating unit, we close it in brackets, and we write a small n to the right, command representing that this repeating unit is repeated several times. So for example, if we have 4 ethenes here, we write the repeating unit and we write a small 4, which means that in this polymer we have 4 ethenes repeated after each other. We can look here at this example. We look at the polymer, and if we count the carbons, we see that we have 8 carbons. Now each monomer had 2 carbons initially, so we can divide this polymer into 1, 2, 3, 4 repeating units. If we look at this polymer, we have 4 repeating units, so we deduce that we used 4 monomers to produce this polymer. Finally, we have 2 types of polymers. We have homopolymers. They are made of the same monomer, so as the reactions which we wrote before, or polymers were made of the same monomer, which is ethene. So this would be a homopolymer made of the same monomers. Now if we have a reaction which makes a polymer but using different monomers, so not only ethene and let's say propene, whatever, a reaction that uses different monomers will give a copolymer. So homopolymers are always made of the same monomer, copolymers are made of different monomers. When we use the same monomers to produce a polymer, we call this reaction an addition polymerization. In addition polymerizations, the monomers should have a double bond. We already said it. The monomers in this reaction should be alkenes. So the first characteristic of this polymerization reaction, it should use monomers having double bonds or alkenes. All the atoms initially found in the monomer are found in the polymer. So we take the monomer, we do not change anything, we remove the double bond, we connect the atoms as they were, and we repeat the monomer several times. The polymer is named by adding poly in front of the monomer's name. So in the examples before we had ethene. When we join ethene together several times, the polymer produced is now called polyethene. Let's say we have chloroethene joined together several times. The polymer produced will be polychloroethene. So we only need to add poly in front of the monomer's name.